Okay, so welcome everyone. My name is Christopher Sesu, and I am your trainer on this very track, intermediate NodeJs. I'm happy to be your trainer, and you are all welcome. So let's begin by knowing how the whole course, the whole thing is structured. So before we begin, today, our aims and objectives are to understand closures. We are starting with advanced JavaScript concept, and closures is the number one on the list. So the aim is to understand closures, the definition, core stack, and function execution context, so we can understand how closures work under the hood. And then we learn about the practical uses of closures. And variables. Not only that, we also learn how to use. Then we learn about the best practices and the common pitfalls in closures. And then we patterns. But first of all, I want to show you how I structured. You'll be hearing me talk, but after talking, you have to, maybe you want to make some research. Decided to construct something for us. Here's our repository, KodeCamp 4. And when you open this repo, you will see closures. We have closures here as the number one directory. And if you open this directory, you have, I've arranged this markdown files according to how it is being arranged in our slides. So the first thing is the definition of concepts. The second is creating closures. And if you click on this concept, you get to see the content and everything, the examples and the explanations. But you don't have to do that right now. Right now, you just pay attention, listen to me, and then try to understand all that we'll be discussing in this class. Just pay attention, listen to me, and then we get along. So my aim is to make you understand what you are learning, not only knowing it, but understanding it, because in software engineering, or let me say software development, it's not all about what you know. It's all about solving problems with what you know. It's all about solving a particular problem where you come across it with the knowledge you already have. And right now we're about going into closures to gain more knowledge about closures and how we can actually use it in JavaScript to, build projects and solve problems. So without talking too much, let's dive into definition and concepts of closures. So under definition and concept of closures, we have explanation of closures. The second item on the list is how closures work in JavaScript. And last but not the least, the lexical scope and closures. So let's explain closures and try to understand what closures are all about before we dive into syntax and all of that. So in general, in programming, a closure is actually a function that has access to variables in its outer function scope. That's its enclosing function scope. So even after the outer function has finished executing, the inner function remembers the outer function's environment, allowing the inner function to operate on that data, even when called outside the original context. So this may sound weird, but as we go further, we get to understand closures in depth, and we understand the lexical scope, the outer function scope, and all of that, how the inner function can recall its context and all of that. So closures in JavaScript, when you create a function, you will not understand it. I go into some few examples. I give you some few examples, but let's first of all try to understand the theory first before we get to practicals, because understanding the theory before practicals is always beneficial. So when you create a function inside of another function, after the outer function is done executing, the inner function still remembers the outer scope. That is the enclosing scope, the scope of the outer function. So for instance, let's say we have a simple function here. I have a workspace prepared already. And if you don't like dark theme, you can let me know so I can change it to something else. I can change it to light theme or anyone you prefer. Let me zoom in a little bit. Okay, so let's assume we have, and the examples that are in those documents I prepared for you, they're the examples I'll be using, so that when you get confused or you want to learn something more, or you want to make some research about something, or any example I've given to you, you go back to the docs, pick the example and examine it. And you can actually reach me on Discord anytime, any moment. So let's dive into this. Let's assume we have, sorry, please. Let's assume we have a function. So let's assume we have a function. And this function name is greet, because we want to greet all the code campers. So we have a function greet. And this function takes the parameter of name. So name is actually the person or the people we want to greet. So this is the outer function. And now from here, beginning of the lexical, okay, let's say beginning of the outer function scope. And here is the end. Let's say here is the end of the outer function scope. So within this function, if you write another function in between this, in between the beginning and the end of this function, the function will recall this outer function's environment. So let's go ahead and declare a variable inside of the outer function. Let's say greeting equal to hello. As you can see, this variable here is declared in the outer function. Now we want to declare an inner function that will get hold of this variable and make use of it in that inner function. So let's declare another function. Say hello. And inside of this function, we want to grab the greeting variable that is inside of the outer function and make use of it in this inner function. So we'll simply log it to the console. Let's say greeting plus name. That is, we are concatenating the name and the greeting. So this greeting is outside of the scope of the local inner function scope. It's outside of its scope, but it can still get hold of this variable here and use it even after the outer function has finished its execution. So let's go ahead and try to use it. Let's just simply return, say hello. So how can we possibly make use of this function? So this here is a closure. The beginning of the outer function scope down to the end of the outer function scope is a closure for the inner function. So to get rid of this, let's say const my greeting is equal to greet code campus. I actually want to greet all of you. You're welcome on board. Okay. So now I want to greet all the code campers. So notice what is happening. When you call this greet, you are referencing this function here. So when you call this function, what is this function returning? The function is actually returning say hello. It's actually returning this function. And when it returns this function, it will pass it to this variable, my greeting. Now, my greeting is now holding this inner function. So you don't just log function like, if it's a variable, I can simply say log my greeting. But this is a function because this outer function is returning this say hello and passing it to this variable. So this variable automatically holds a function. So you have to call it like so. So in order to get access to the inner function, we'll call my greeting. My greeting is now referencing the inner function, which is say hello. Now we'll call my greeting and then we'll try to run this code. Say node. Let's see the structure. Okay, node. Okay. Node one closures slash test JS. And then we'll see hello code campus. Even when this function, the outer function has finished its execution, the inner function still remembers its enclosing environment and the variables, everything inside of it. And before we proceed, this name here is also a variable. This is actually a pattern. We're actually exposing this variable to the outer to the global scope or the outer scope so that the program can actually get access to this name and then make use of it. Because without exposing this name, let's assume let name equal to code campus. And then remove this name here. Oops. Actually remove the name. And then you come here, remove this as well. And then try to log this. Hello code campus. But inside of this, you cannot access anything outside inside of this function. Even if you want to change this, you can't change it because for you to change it you can't change it at runtime. You have to come back to your code every other time to change this name to something else. But in order to access it, we have to expose it to be able to be accessed outside of this greet function. So that's actually what's happening here. And this is actually a binding. A name is a binding. When you declare a variable, and then you declare a value, that value is being bound to that variable. So now we declare name. JavaScript, it's a dynamic programming language. It's not static. So we don't have to specify if this is a string or a number or whatsoever. This is actually a string. So we declare a variable name, and then we assign it to this value, code campus, which is a string. By doing this, this is what we are actually doing. For now, if you log name and you call this function, name will be undefined. But by the time you call this function and you pass in an argument of code campus, the name here is being bound to this code campus, and then the value of the variable name is now code campus. And then when you call this function, it executes and return the inner function to the outer one, and then you call the inner one, then you get the result of what you are expecting. So that is it for that. Now we actually have a clue of what closures are. But then how closures work in JavaScript, we are still confused about that. We don't really know how closures work in JavaScript. And that's what we're about to learn. Let's just go ahead and see how closures actually work in JavaScript. So in JavaScript, closures work through the concept of lexical scoping, as I earlier stated. And what is lexical scoping? We're just hearing lexical scoping, and we don't even know what the lexical scoping is. So variables are accessible within the scope they are declared in, along with any nested scopes within the scope. This is confusing, but in a minute, we will see that, we'll visualize that, and we'll see how variables can be accessed in the environment they are declared in. So along with any nested scopes within that scope, And for you to understand this, you need to understand the scope chain. I will get to that in a bit. So variables are accessible within the scope they are declared in, along with any nested scopes. Within that scope, this means an inner function has access to variables declared in its outer function. That's sweet. Even after the outer function finishes execution. Okay, so this process is a kind of tedious, it's kind of confusing to hear. So let's try to break things down. Function creation. When a function is created in JavaScript, it captures a reference to its surrounding lexical environment. This environment includes all variables and functions declared in its outer scope. And we'll understand what is an inner scope and an outer scope in just a bit. Stay with me. Secondly, when an inner function is declared, any inner functions defined within the outer functions have access to this captured environment. This allows them to access and manipulate variables from the outer scope. That is, even after the outer function has finished executing, the inner functions can still access variables from the outer scope. That is within the environment of that outer function. So closure formation, how are closures formed in this process? The combination of the inner function and its captured environment forms a closure. This means the inner functions carries with it the necessary context to access the captured variables, regardless of where it is called or when. That is sweet. So in this case, when a function inside of another function is called, it recalls and remembers all the variables and its environment. That is the enclosing environment of the outer function. And for this, let's modify our function a bit and see what we got as well. Let's say in this function here, this greeting, we can pass this greeting as a parameter to this say hello. And then you see how this my greeting is referencing this say hello. So we can actually do away with this and then pass greeting as a parameter to this function. And after passing greeting as a parameter, we'll come here and then pass hello as an argument to this as well. Then try to execute this function. You still see our results. Our result here is hello KodeCamp. Let me clear my terminal and run this once more. Hello KodeCamp. As you can see, this my greeting is referencing say hello. And when you call this greeting KodeCamp, you pass in this argument. After this is done executing, it will pass control to the inner function here, which will log the greeting plus the name. We're concatenating this. Let me say note. You can actually see greeting.concatenate. Is it concatenate? The concat. I'm trying to make some mistakes here. Concat, and you can actually log this and you see hello KodeCamp. So concat is actually an inbuilt function to join arrays or a string. It's an array of characters. A character is just a single letter word. A single letter. But when it is string, it's an array of characters. But because JavaScript is dynamic, that is handled behind the scene. Okay, so that is sweet. So we now have an idea of how closures are formed and how closures actually work in JavaScript. Now, moving on, let's explore lexical scope and closures in depth a bit. Okay, so lexical scope and closures, we've already discussed what a lexical scope is, but we'll have to take a look at the lexical scope and closures. Even though we've discussed more about it, closures are created at function creation time, not execution time. Listen to this. Closures are created at function creation. By the time you create a function and create an inner function inside of that function, that is when closures are created, not execution time. Because immediately you create an inner function inside of another function, that is when JavaScript, this person is, what he's doing here is actually a closure. Take note of this. When you execute this function will have to remember its outer scope and form a closure. So the captured environment persists even after the outer function finishes. That is the sweetest part of closures. How can an outer function finish execution and the inner function still recall its environment? That is sweet. So inner functions can access and modify variables from the captured environment. So closures are powerful tools for data encapsulation and creating private variables. And then let me show you, before we go into private variables in depth, I want to show you something. So let's try accessing, okay, let's revert this to how it was. Let's try accessing greeting. And then clear our terminal and run this once more. We got an error here. Greeting is not defined. This is sweet because greeting is a private variable and only the greet and the say hello function can get access to this function. In our global context, we can't get access to greeting. We can only get access to greeting in the greet function scope, in the greet function context. And that is sweet. We actually, closures makes our life easier in JavaScript. Now we have a clear understanding of what closures are and how closures are being formed. But that is not all. We are still confused. Even when I started learning closures, I got confused at first. We will get clear, we will get to understand closures in depth in a bit. So moving on, the core stack. This is where we understand closures in depth. The core stack. What actually is a core stack? A stack, it's a LIFO data structure. By LIFO, I mean last in, first out. The last item being pushed to the stack is the first item that will be popped from the stack. So for example, we have this function. This is this border here, this blue border, the outer one is our global execution context. And this inner one here is our function, the function is named one. It is our function, it's a functional execution context, which is a local execution context, also known as a local frame. And this outer one is known as the global frame. So when you call this function or when you invoke this function is being pushed to the core stack. And since we have just a single function being pushed to the core stack, after this function is done executing, it will be popped because it is the last item in the core stack and it will be the first item to be popped from that core stack. So immediately it is done executing, it will be popped from this core stack and return control to the global context. This sounds like what you don't know. We'll get to that in a bit. So moving on, this is just a single function. But what if multiple functions are called? Let's get to that. Now we have a core stack here that has about 3 functions, the function 1, function 2, and function 3. Now when you call function 1, look at what's happening. The function 1 is being pushed to the core stack. What is happening? Function 2 is being called or invoked in function 1. So when you call function 1 and it's pushed to the core stack, it will encounter function 2 and say, oh, there's another function, push this also to the core stack. And the function 2 will be pushed to the core stack. And when you try to run function 2 or try to evaluate function 2, it will encounter function 3. You say, oh, yet another function, push it to the core stack as well. And this is being pushed to the core stack. And they are being pushed in the order in which they are called, function 1, 2, and 3. So we have the last function pushed to the core stack, which is function 3. Now, when it tries to execute, you can see there's no other function in this console trace. It's an inbuilt function, and this has nothing to do with the core stack. So when you try to execute these 3, there's no other function in this, then it will execute and function 3 will be popped from the stack and control will be returned to function 2, which is here. Function 2 will finish execution. Now, because function 3 has finished execution and control is returned to function 2, function 2 will finish execution as well and return control to function 1. Then function 2 will be popped from the stack. Popped, I mean removed from the stack. And then control will be returned to function 1. And then when function 1 is done executing, control will pass back to the global context and function 1 will be popped from the stack. Popped, I mean removed. We know we have this array method, array pop. You know what that means, so I don't have to explain. So this is how the call start actually works. So in order not to confuse ourselves, back to this function, I have a tool that we can actually use to visualize this. This tool, the link is in the readme.md file. You can actually find and play around with it. It's actually it's a good tool. You can get to understand the tool better and know what's happening under the hood, but don't misuse it. Try to understand this first before using the tool. Now, what I will do is come back to our function here, function 1, and then we say let a equal to 2, return a. What we do here is copy this function and then go to our tool. The tool's name is python-tutor.com/visualize. Here is how you visualize your code execution. We have the supported languages here: Python 3.1, 3.6, Java, C, C++, and JavaScript. But since we are working with JavaScript, we don't have to worry about other languages because we have no concern with that. All we have to do is try to execute our code and visualize what is actually happening. So let's paste our code that I copied. I actually copied the code. Here is the code. And then we try to execute it. Now, when I click this visualize execution, see what happens. Now, please wait, your code, okay. To this. See object. So, or I don't know that you object, nor is an object undefined, referred to as first class objects because they can assign to variables, they can be used as methods. So that is why they are referred to as the reason why you are seeing a this function under objects. Immediately you invoke your global frame will be created. And we have this one function, which is in our global frame. And the reason why we are just having this and nothing is happening, all these buttons are disabled because we forgot to call this function. So let's go back and then invoke our function 1. And then when you try to execute this function now, and these buttons are enabled. This function will be, there are 4 steps with this function to finish execution. Now pay attention. Let me zoom in a bit. Now keep looking at this and then look at this. The next line to execute is indicated here with a red arrow, and the line that has just executed is indicated with the green arrow. But right now we're about executing 1 because immediately we execute our file, the function 1 will be invoked. Now look at what happens. Once it is invoked, can you just see this? This function is pushed to the stack where A is undefined. The function is pushed to the stack and it has started execution, but the function, the line that has just executed, we have just executed this function and all the variables inside of it are not yet assigned values. That is the reason why A is still undefined. Now moving forward, let's execute this. When you execute this, oh, this is sweet. Can you see that the global frame is here and this function frame is also here? And then the variable A is declared in the local frame, which is the function frame, and A is bound to 2. Now moving forward, the next line to execute is the return. When you click next, the return value here is 2 because the value of A is assigned, the value of 2 is assigned to A. Now this function is returning A. And when the function encounters a return statement, the function will complete its execution and pass control back to the global frame. So let's see what happens. When you click this button, the control is being passed back to the global frame. That means you are done executing your function and you pass control back to the global frame. And the result is now in the global frame. So you can now make use of your result. So we are returning A. Now, when we return A, this function returns A, and we want to assign it to R. R is equal to 1. and we want to log this in the global frame R, not A. Now let's visualize this once more. Great. So now let's execute this, execute, return value. As you can see, now R is not in the local function scope, but it is in the global function, in the global execution context, which is a global frame. Now, R has a value of 2 because when this function is done executing, it will return its value and pass it to the global context. And the global context, R, is declared in the global context, which if this function returns a value, the value will be assigned to this R, and this 2 is now assigned to R. Now, look at this empty box here, print output. When you click next, the value of 2 is being logged. Oh my, this is sweet. Can you see how things work under the hood? Now, immediately a function, the local scope, the local frame or the local functional scope is created. That function is being pushed to the stack. And now, because of time, I will allow you to play around with this, and try to come up with, try to imagine or try to understand what exactly is happening. We won't go ahead and explain this because I've explained that, and you should have an idea of how this will work. So you should try writing this code, copy it, and then visit that at 2, and then try to paste it and then execute it, and you understand how things work under the hood. So moving forward, practical use cases. That is the practical use cases of closures. So closures, we have few uses among the rest of closures. There are many uses of closures. Closures can be used to create private variables and methods, and callbacks with preserved state, higher order functions, and partial function application. This is a kind of an advanced concept. We're not going to go in depth into partial function application, but we write a simple code that we kind of visualize or show us how closures are applied. But in the callbacks with preserved state, everything is in the docs. You can go ahead, play with it. I'll just try to give you some examples and then understand what's going on. So using closures to create private variables and functions, create closures in event handlers and callbacks and higher order functions. So actually, we play around with 1 and 2. We give examples on 1 and 2, 1 and 3. Then 2, you can go ahead and play with it. I know you are all back-end developers, but then creating a button in HTML and linking a JavaScript to an HTML document is simple. It's a kind of a simple thing for you to do. So you can go ahead and play around with 2. But we're not going to play around with 2. We play around with 1 and 2 and 3. So when closures can create private variables and methods within function scope, yes, that is preventing them from being accessed directly from the outside, as we demonstrated earlier. So this promotes data encapsulation and modularity, leading to cleaner and maintainable code. As developers or software engineers will always say, code is being read often than it is written. So if you write a good and clean code, they will read it good and clean. But if you write anyhow code, they will read it anyhow. So how can we create closures with private variables that cannot be accessed outside? So this is how we can go ahead and do this. Let's assume we have a counter. Let's say function counter. And this counter has a private variable of, let's say, let's count equal to 0. By method, I mean to this counter variable and modify it or anything they want to do with it, because it can actually locate it and manipulate it or play with it, use it, something like that. So we have a method which is this method is increment. This method is simply to increment the count. So we'll simply say count plus plus. And count plus plus is the same as saying count is equal to count plus 1. This is just a shorthand. Count plus plus is the same as saying count is equal to count plus 1. When you access count here is 2, and then we say 2 is equal to 2 plus 1, 2 becomes 3. If 0 is equal to 0 plus 1, 0 becomes 1. And that is it. So another method here that will return our count, because we can't access this count variable outside of this counter function, because this is now formed. This is now a closure. So we need to get the count. All we need to do is return count like this. So how do we get access to these functions? We can actually give them, make it function expressions that we can return here, but we've declared this function. All we need to do is we return them as objects. We have increment and get count. Now, if you want to make use of this function, I think I should zoom out a bit. Like, so if you want to make use of this function, all we need to do is we say const counter is equal to, let's see, counter f is equal to counter. Then we invoke this function. Now, when we invoke, look at what's happening. We have, how many methods do we have here? Increment, which is a function. It returns nothing, which is void. Get count returns a number. Now, let's try to invoke these functions. First of all, we say counter f dot increment. Increment is a function, so we need to invoke it. And then we say log counter f dot get count. Get count is also a function, so we have to invoke the function as well. So now we clear our terminal, and let me expand this a bit. Then we call our function, and we have 1. So once more, we increment this once more, and we get access to the count once more. At first, it was 1, and we increment it, and we get the count, it's 2. And you can see the state is being preserved. And now let's try to access the count outside of the counter function. Log count. Then we log this to the console, and we have an error here. Count is not defined, because this is not accessible outside of this function. So that is how private variables and methods are being created. And that's how closures are used to create private variables and methods. As you can see, increment, get count, and counter all are private. And let's try to call increment directly like this without accessing it from the counter function. We also get an error. What is the error? Increment is not defined. Can you see how some closures are? Okay, so moving on, we'll skip closures in event handlers and callbacks, but I will talk a little about it. Closures are frequently used in event handling scenarios where callbacks need to return data specific to the event. So the closure allows the callbacks to access variables from the outer function scope, even after the event has occurred. Okay, you can go ahead and play around with it, copy the example, play around with it, no problems. But then we're moving on, we have higher order functions. And how can closures be used in higher order functions? Okay, so let's give an example. Closures play a crucial role in implementing higher order functions that take other functions as arguments. You know, higher order functions are functions that take other functions as arguments or return functions as output. So by preserving the behavior of functions within closures, higher order functions can be created for tasks like, okay, let's take for map, filter, reduce, sum, and all of those higher order functions in JavaScript. They all use closures under the hood. So let's try to emulate the map function. So in this case, the map function, first of all, we try to do it like this before doing it the other way around. So like this, I mean, let's do it like this. Map, because map is a reserved keyword in JavaScript. So I prefixed it with an underscore so as not to cause conflict. So here we take an array and a callback that will act on this array. Now, so what do we actually want to do? Now, a closure will be formed. Now, when we say const new array is equal to an empty array, this new array cannot be accessed outside of this map function. So what do we want to do now? What we want to do is we want to apply this callback to this array. So how do we want to apply? The callback may be any function. So maybe you want to double all the numbers in the array, you want to triple all the numbers, or you want to actually you just want to return a new array that is being acted upon. But data mutation is highly prohibited in JavaScript. So you don't have to mutate the initial array. You don't have to create a new array with the mutate the data you've acted upon. So all we need to iterate all over the array, and then act over the input, the values of the array, and then add those new values we acted upon to this new array, then return it. So how do we go about that? You see, for const element of the array, for each element of this array, each element for const of this a for loop, for off loop. So I know you are used to this. So for each element in this incoming array here, apply this callback function to the element. So after applying the callback function to the element, what do you need to do? After applying this callback function to this element, then push it to the new array. Like so. Push it to the new array. So when you're done applying this callback function on every element in this array and pushing it to this new array, simply return the new array, but not the old one. And now let's test this out. What's happening here? We have a new array here, which is a private variable, and a closure is formed. And now we're acting, the push here is also a higher order function. We're acting on this new array internally. We can't access this new array outside, so a closure is formed. So this is how closures are helpful in higher order functions. So now when we see we have an array of numbers, which is equal to 1, 2, and 3. So we want to actually double these numbers. So we see map. The first thing we take is the array, which is the numbers, and then the callback function. And the callback function, you can actually do something like const double is equal to function, which we take each number as this element here. The element here is the number, it's referencing the number, and double the number. That is double, I mean multiply the number by 2, and then return it. Now we pass in the double function like this, or should you say log this function to the console? Like this. Let's try to test this out and see what you've got. Great. So what's happening? 5, 3, 4, 5. Oh, I'm saying plus 2 instead of multiplied by 2. It's double, not add 2. Okay. So we have 2, 4, 6. 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. And 2 multiplied by 3 is actually 6. So as you can see, we've emulated the map function, and then we've done this. And you can actually do this with the array prototype, which is prohibited, except you have a special reason, a good reason to do that. And you can actually cut this off from here, bring it in here directly, like so, and then do away with this. And then your function will still work as expected. So here we have the callback. This is our callback function. And then we have the array, which is a number. And then inside of this function, we don't actually, that's why we, the function abstraction is highly encouraged. You don't actually know what, you don't actually need to know what's happening in the function, but you need to use it. So without knowing what's happening in map, we've been using it, but if you still have interest in knowing what's happening in map, you can actually go ahead and use it. So that's how you can actually extend web array, and all JavaScript objects they can be inherited, right? So an array has, you can add a map function to the array prototype and then use it. Have array prototype dot, like as you can see, we have the push. All these higher other functions are on the array prototype. So you can actually add yours, like array prototype map is equal to function. And you can go ahead and write your logic in this function. You can pass in an array. You can go ahead, this, you can see for let I equal to 0, I is less than or equal to this dot length. And in this case, this is the array you are acting upon. I plus plus. And then after doing this, you can say, what do you want to do? Is it a map function? Okay, so how is it going to do this? You can say, okay, your array here, let array equal to, let array equal to this, right? This is the array you are acting upon. So you can just come here and you can see array.push callback. When you push the callback, you actually passing the callback here that can actually pass in a callback that will be acted upon. So we push this, they say this, the index at the moment, the current index, this is the current index and the elements at that current index, and what this, which is the array. And all of them, when acted upon, you return it. Okay, that's by the way, I just trying to explain how you can add a map to the array prototype. Okay, so moving forward, higher other functions, we're done on how to practicalize using closures to form higher order functions, using closures to create private variables and functions and all of that. For partial application, let's just, it's not listed here, but then let's just go ahead and give a simple example on how closures can be used to create partial applied functions. So we can say we have a function add that take x and y. So it simply returns x plus y. And what we want to do here, we say const add 5 is equal to add bind. I'm not going to explain bind. You can make the research by yourself. No, the first value is no at the moment, initially. Then add the first value to 5. Now when you call this function, say log add at 5. And this time around, you can pass in 20. And what will happen here is 20 will be added to 5. Initially, 20 was null, but now, sorry, the first value was null, but now the first value is 20. Now, if you try to execute, let's run our code, and we have 25. 20 plus 5 is 25. Now, this is a kind of tricky. This is the same thing as saying function add, and then we take in x. Then we see another function add 5. we're taking, okay, let's say we're taking 5. We're taking x, y is equal to 5. Return y plus x. And here you simply return this function. Can you see how x here, it's only accessible in this function? And after executing this, you can still access x in this one. So this is the same thing as this, but then this is a kind of more mature. Yeah, let me say more mature. So that's how closures are being used in partial applied functions. Let's not go in depth, but at least you have an idea of how to use closures in higher order functions. Okay, so moving forward, closure scopes and variables. Closure scopes and variables. So accessing variables in the parent scope, modifying variables in the parent scope, understanding the scope chain in closures. Yes. Actually, for you to understand closures, for the knowledge of closures to be complete, you have to understand the scope chain in closures. So let's actually see how we can access variables in the parent scope, modify variables in the parent scope. We've been doing that, but we don't know that is what we've been doing. So I will actually hit the target now and show you that, oh, this is what you've been doing. You'll be accessing variables in the parent scope and you'll be modifying them. Then we'll understand the scope chain. And then from there, we'll move to the next item on the list. So accessing variables in the parent scope. Let's jump into writing some code. I don't want to explain that, but let me just explain it a bit, because with examples, you can be able to explain it by yourself. So closures allow inner functions to access variables from their outer function scope, even after the outer function finishes execution. And the reason why I keep repeating this is because I want you to build on the recursive learning pattern. The recursive learning pattern is you learn a concept now, you try to understand it, you leave it for a moment, try to grab it, come back. And that time, you are not trying to actually start afresh and learn the concept. You are trying to go in depth and understand it bit by bit. So when you understand what closures are all about, you try to digest it and you understand the basics. Now, oh, closure. So in this part, what should I call this? In this part, what should I call this? And what is this actually doing? So that is where I'm taking you to. Recursive method of learning. You learn recursively so as to understand in depth what is happening. So in our previous function, the counter function here, we have a private variable, which is count. And the count here is 0. Now, this count is a private variable, but it is in the outer scope of the function I will declare now. Let me declare another function, increment. And this function simply increment count and logs it to the console. Count, like so. So this function is accessing this variable in its outer scope. So you use this function to explain the two terms. It is accessing this variable in its outer scope, and it's also modifying it. Right? I think that is it. Modifying variables in the parent scope and accessing variables in the parent scope. Okay. So in this function, this is its parent scope. From here, parent scope begins and it ends here. So anything within this function increment can be able to access it. Not after, but before the function. Can I actually say let count 2 equal to 2. And then you can actually increment count 2 and log count 2 to the console as well. Yeah, so this function, the inner function, is actually accessing variables from its parent scope and modifying them. Can you see how closures are great and important? Now, if we return the increment, we can actually say return the function like this. But in my pattern of programming, I don't like returning functions like that. I'll say return increment. It makes things clear to me. So in this case, when we try to call our function, let's say counter one is equal to counter. Let's invoke our counter function. And our increment, we are returning this increment, yes. So now we say we call counter one because this is already logged, so we don't need to log it here. This is already logged to the console. Now we try to run our code, and we have 1, 3 because initially our count is 0 and count 2 is 2. So when you increment it, it becomes 1, and we increment count 2, it becomes 3. So we log to the console. So this the inner function is accessing the variables in its parent scope and modifying them. So that's how simple the accessing variables in the parent scope and modifying variables in the parent scope is. That is what it is. We can actually declare private variables in the outer scope and then access them in the inner function. That is the closure scope and variables. So understanding the scope chain, and this time around, I intentionally left a little diagram in our doc so we can go there and try to understand what's actually happening. So let's head over to our docs. And where are we? Scopes and variables. Yes. And then we'll come in here. Scope chain. So what is this saying? Okay, in JavaScript, the scope chain determines where a variable is looked up when referenced within a function. So when we have an outer function, for instance, this function, we have another variable count, late count 3 is equal to 4. We can actually access count 3 and log it to the console as well, count 3, and try to run this code. We have 1, 3, 5. We have count 3 is 5. So this is the closure scope. This inner function can access variables in its local environment. Let's add count. Let count 4 equal to 6. Now count 4 plus plus, and then let's add count 4 to our logged count and clear our terminal and run it once more. 1, 3, 5, 7, because we have 6, when incremented becomes 7. So when this function, the inner function can access variables in its local scope, in its parent scope, and in the global scope. So that is the scope chain. So take a look at this diagram. Oops, where's the diagram? Take a look at this diagram. This is the variable scope. That is the local scope in the inner function. This is the inner function, the variable scope, the variables declared in the inner function. So this is the inner function scope. The inner function can access variables in its scope, and it can access variable in its outer scope, and it can access variable from its global scope. And in our tool that we've been using, if you try to run this code here, as you can see, immediately the function starts execution. This global frame doesn't have access to this function frame. It cannot access two. It's just as if I have two people standing, one standing by my right and one by my left. So the right person can actually get access to me, but not direct access to the person standing by my left. So this global frame cannot get access to this because this frame is different. It's a local frame from this. But this one function can get access to its global frame because it is actually coming from that global frame. But when the function is, the global frame doesn't know what, okay, I have a child, the child went out to play. I don't know what the child is doing there, but when the child left home, he actually knew what I was doing before he left. So he actually has an idea what I'm doing, but I don't have an idea what my child is doing out there. This is what's happening. The global context doesn't have an idea what this function is doing. See, it returns control back to it with a value or anything that it returns. So, oh, this is what we're doing. You try to process this value or do this or do that. So when your child returns something, oh, you went to play, this is why your body is dirty. Okay, so that is how this thing is. As simple as that, nothing more than that. Okay, so now that we've understood the scope chain enclosures, let's move on to the next item. And sorry, my bad. If you have any questions, you can drop it in the chat and I will answer you right away. So closures in asynchronous JavaScript. Closures in asynchronous JavaScript. We'll first of all look at closures in set timeout and set interval, closures in promises, and closures in async await. And the reason why this is broken down into pieces is for you to understand every sub context. Understanding closures is good, and that's right. But there's this thing that learning by doing, it's more let me say more important by learning by what should I say? When you're doing what you're learning, you're actually understanding it. But when you are just reading it and not doing it, you may get confused on the way. So set timeout and set interval are actually asynchronous higher order functions. And in promises, you can use closures in promises, and you've been using it, but you just don't know that that is what you've been doing. And closures in async await, you've been using it as well, fetching data asynchronously from APIs, but you don't know that, oh, this is what I'm doing. I'm using closures. Okay, so let's dive into using closures in set timeout and set interval. So set timeout and set interval takes a callback function as an argument and execute it after a specified delay, a delay for the set timeout and an interval, a specified interval for the set interval. So closures are often used within these functions to create callbacks that have access to specific data or state from the surrounding environment, as I earlier stated. The functions inside can have access to the outer, the parent scope, that's the variables in the parent scope. So how is this actually done? Let's try this out and see. Let's give an example. And in here we have, let's say, greet after delay. We have a function greet after delay. And this greet after delay takes a name that after the delay, the function will greet the person. So we have a set timeout. And if you are in the browser, you can do something like window.set timeout like that. But this is not a browser. You don't do that. You can actually say global this dot set timeout. This will work, right? Because global this, we'll talk about global this in our next, in our subsequent classes, and how what it means and all of that. So you will see set timeout or timeout, and then this will take another function. What this function is, it will execute after a specified time in milliseconds. Let's say 2000. This is 2 seconds, right? So after this, we see log. You can use template string hello. I don't want to use this because we are not yet year 6. Hello name. Oops, using caps. No. Hello name like this. And then we're trying to invoke this function. Greet after delay. Greet after delay. Code campus like this. And then let's execute our code. 1, 2, and kaboom. We have hello code campus. And you may be saying, okay, so there's no variable in this outer function that this set timeout is accessing. There is, as I actually mentioned, this name here is in the outer, in the parent scope. You can actually remove it here and then declare it here, let name equal to. But this time around, we are not allowing it to be accessed outside of this function. This is the only way we can access it and pass this parameter. We can access it and pass an argument. So it is in the parent function scope, and this set timeout is a higher order function that is also accessing it and passing it to the inner function, which we evoke after 2 seconds. So you can actually do away with this. You don't have to use template string. You can do something like this. Hello. Then you see plus name plus this. And then your code still runs. 2 seconds, kaboom, hello, code campus, and this is 0, not O. Okay, so that's great. And moving on, you don't even have to do that. You can actually say, hello, oh, this should be hello dot concat name dot concat this, and your code still runs. 2 seconds, kaboom, hello, code campus. So that is just it. And that is how we can use closures in set timeout and set interval. Set interval is just it will execute after a specified time. You can actually change this to, what should I say? Okay, let's say set interval, and the interval, okay, let's execute this and see what happens. 2 seconds, push. After 2 seconds, hello code campus, hello code campus, hello code campus. I know, listen to me, answer me, I'm greeting you, hello code campus, and oh, that's what the function is doing. Okay, so let's stop this and continue. So that's how closures can be used in set interval and set timeout. Okay, so next on the list, how closures can be used in promises. Promises are actually objects representing completion, a completion of an asynchronous operation. It's either can be resolved or rejected. That is, on reject, it's a failure. It's either it will pass or fail. So when promises are used, it can be used with the promise handlers like then and like dot then and dot catch to capture the state of the data of the surrounding context, something like that. So when it's an error, you catch it. When it's resolved, you then, and then an inner function in the then, you capture the result and make use of it. So how do we use closures in this, and how do we make use of that? Okay, coming back to our text editor here, we show an example with delay with message function, delay with message. Then we have message delay ms. Ms is milliseconds, delay in milliseconds. So what is this function returning actually? This function is returning a promise. Return new promise. Remember, I said promise is what? It's an object. Object can be evoked using a new keyword. That's great. So inside of this function, it takes a higher order function with a resolve function here, like this, with a resolve main and reject. But in this case, we're not fetching data from anywhere, or we're not doing anything that would prompt this promise to be rejected. So we're just taking the resolve, and inside of this inner function, what do we want to do? We use a set timeout that takes in another higher order function. And this time around, how many seconds do we want to execute this? The delay milliseconds that will be passed from the outer, that is the parent, to the inner function. So after this millisecond, what do we want to do? We want to resolve the message. So in here, resolving the message, how does it act on the message? This is how it acts on this, the resolve function will act on this message. So when you call this function, delay You can call it directly like delay with message, and you pass in a message of code campus, or you say code camp. Pass in a message of code camp. You see dot, then when it's resolved, it returns a message, and you can access this message in this function. You see log message. So let's run this function. Okay, we pass in a message without passing in the time. Let's say 1 second, and run this. And in 1 second, you see code camp. Okay, and we can actually see hello code camp, and you run it. Even when passed here as arguments. So we can actually use another function to, access this, form another closure. Let's do away with this. And we can call another function greet after delay. And this function will take a name. And inside of this name, we can say return. This function is also returning a promise, because this here is returning a promise. And when the promise is returned, the control is passed to this delay with message. And this greet after delay will return this delay with message here. And what we want to do is we want to say delay with message. And this time around, we say hello. We want to abstract the implementation details of this greet after delay from the users of this function, name, like so, and then we pass the time, which is 1 second. And after this time, we can now successfully use our greet after delay. Now, all we have to do is just pass the name code camp. And after passing the name, it's a promise. Always remember that this is returning a promise. So then message, want to log message. But if it's an error, though no error, we say catch error, can also log error. And if we run our function once more, we have hello code camp. So now in the second function, we're also using closures here to access the name. The name is in the parent scope, but we're accessing it in this delay with message. And this message and delay MS are also in the parent scope, but we're accessing it in the inner function. So that's how closures can be used with promises, actually. And last on this list, closures in async await. And closures in async await, when you use a fetch function, actually, this closures in async await, when you use a fetch function, it takes, you can make a custom fetch function that takes a URL as a parameter, and that URL can be accessed in the fetch function you are using. It's an async function, so you await and fetch the URL. As an example, you can fetch the URL, and that URL there, it's in the parent scope, but you are accessing it in the inner function, then making use of it. And how can we do that actually? Let's rush over this example. You can say async, that is making this function asynchronous. And when we discussed function execution context, we did not discuss asynchronous function execution context, because in this case, that is where the web APIs, the event bars, the task queue, and all of that comes in. But later in our subsequent classes, we will talk about that. So we say fetch data URL. And this URL is in the parent scope, but now we want to access it in the inner function. So we say const response is equal to await fetch URL. And when I mentioned global this is a global function. Now let me show you something. Global this dot fetch. Can you see all the methods on the global this? Can you see them? And fetch is on the global. Now you can actually see, without using the global this, you can still access fetch. But you can still see global this fetch. As in Windows, you can say window fetch. Or in Node environment, use global this. Okay, but you don't have to do that. This is very, very okay. Await fetch URL. So you're accessing this URL in the parent scope and then fetching the data you need. And after fetching the data, you want to convert the data to JSON format, JavaScript object notation format, so you can send it through the network. You know, JSON is not heavy and it can be transferred through the network easily. So no matter how much the data is, by using JSON, you can transfer the data, and the client will grab the data and convert it back to JavaScript and you know, quickly make use of it. So that's the reason why JSON is used for transferring of data and all of that. It's used for many things. So you see const data is equal to await raise JSON. You are converting the data to JSON. Now we simply return data. So after returning data, we can actually, in an asynchronous function, you can see async. You can see main or anything. Let's say main, because this is the main function that we async function main. This function will execute our fetch data function. So in this, because we're using async await and we're not using promises, we are not using a promise object. We're not using a promise object, so we have to capture errors in this differently. We say try catch block. Here, in the first block, is actually to resolve and get your data, your result, your actual result, the result you're expecting. But in this catch block here, it's actually to catch your error. So you can say error, console error. You can see error and error. You can log the error on the console. This error here. Okay, so why am I getting an error expected? Okay, comma. And in here, this is where we'll fetch our actual data. We'll say const fetch D, that is fetch data, is equal to await, because it is an asynchronous function. And this here is also an asynchronous function. So we can use this asynchronous function here. Fetch data. And we can simply say we're fetching data from HTTPS / JSON placeholder dot typecode.com/todo/1, like this. And after fetching the data, we log the data to the console. Data fetch D. Because we're not doing any extra work, we've already handled the work here. After fetching it, this function will convert the data to JSON. And what we want to do here, after calling this function, it will actually return the data in JSON format and then pass it to us, then we'll log it to the console. Okay, so let's execute this and see what we got. Okay, I've not called the main function. Now you can see main. And even after calling the main function, you can see dot then No. Okay, it's an AC, not a promise. After calling the AC, just call it like this. Let's say dot. Then, and then you can say if there's anything to do, if there's nothing, that if there's an error, catch, and this is where you can pass in a function. Then if you want to throw an error or do something, or exit and tell process exit one, and the 0, it means everything is successful, but when you exit with 1, it means it's not successful. Or you can leave it empty like this and then execute your function. And then the data is fetched. We have data, user ID 1, title. Okay, is it to-dos? Okay. The title is the lectures out. Oh, team. Oh, completed is false. So we fetched our data, and then we can go ahead and remove this. Let's say users, and then fetch users, and we wait for the data to, we have 10 users here. Okay, and now we are handling this really well. Now let's remove this S here, and then try something. I just want to throw an error. Okay, empty. Okay, or let's, should I say this? I just want to throw an error here. Okay. Error. Okay, so now we have encountered an error, and this, we couldn't resolve this function, so we have an error now. We have our error here, then the error is, the type error is failed to pass URL from, this URL is not correct. Okay, so this is how we can use promises in this, because this is in the parent scope and we can access it here. And in here as well, everything, after accessing this, we can actually use this function here. And when executing this function, pass this, even after this function is done executing, we can get access to this URL from the parent scope and then make use of it. Okay, so that's sweet. Moving on, the next item on our list is common pitfalls and best practices. So avoiding memory leaks, handling variable conflicts in closures, and best practices for using closures in JavaScript. So avoiding memory leaks, we don't really have any examples on that because I just want to leave it out for a reason is best, which is best known to me. But avoiding memory leaks is, well, JavaScript is a garbage. It's a garbage. Should I say it's a garbage collected language, or it uses a garbage collection by default. Garbage collection is where after declaring a variable, assigning a value to it, after using that value, the memory claimed assigned to that variable will be reclaimed and used for something else. So it's dynamic and it's garbage collected. Not languages like C that are static languages and are not, you have to garbage collect manually, not automatically. So, but due to the fact that we don't have examples, I want to show you something very light. You see, log, you can actually see const A, late A equal to 20. Now you say log A. And then in here, you want to garbage collect. That is, you want to clean A. You don't want to assign, and you want the memory assigned to A to be free. You want it to be reclaimed. So you can actually say A is equal to void 0. Then you say log A. Don't worry, I'm using this void 0 for a reason, and we'll talk about that in a bit. Log this. Can you see? A here is 20. After using A, we assigned undefined to A, and A is now undefined. I don't even need to explain void 0 because look at it, undefined. So when using a void here is, when using void in functions, you are simply saying, okay, I want you to do something with this function, but do not return a value. Just execute the function and everything inside of the function, do something with it. Everything inside of the function should be executed, but do not return a value. Okay, say you are saying A, instead of saying B, under the hood, this is what is happening. A is assigned to void 0. But here, simply undefined. Like this. or you can see A is null. And after using A, you assign it a null, and the memory that was assigned to it is being reclaimed. So you don't have anything to worry about. That is garbage collection. That is manually. But the system, JavaScript engine, that is the V8, the Spider Monkey, and the rest, they are doing that under the hood for you. So you don't need to worry about that. So that's it for avoiding memory leaks. So closures can potentially lead to memory leaks if variables captured within the closure are not properly released or garbage collected. So to prevent this, make sure to release any references to unnecessary objects or data within the closure that when it's no longer needed. So consider using weak references or cleaning up event listeners and all of that. So that is the reason why it is very, very important to know what you're doing, if possible, to master the JavaScript language so that you garbage collect things when it's necessary. But if you don't know, you are just coding, you are just assigning variables and coding along. When it's time to garbage collect, you don't know, and that is what we call memory leak. When you run your application, when it's time to garbage collect and it doesn't happen, the memory, it will keep consuming the memory. It will like a kind of crash the system or something like that. The memory, it will exhaust the memory, something like that. And handling variable conflicts. So this is a best practice actually. You need to use, if variables with the same name exist in both, this one is very important. So if variables with the same name exist in both the closure scope and its outer function environment, the variable within the closure scope takes precedence. If there's a variable, let me just show you an example. Let's say ex, let a equal to 2 log a. Let a equal to 3. Now let's run this, let's call our ex function here. What's the value you are getting? You're getting 2, right? That means if there's a value here, now what is happening here is there's a conflict between these two variables. They have the same name, AA. So this variable takes precedence. This one overtakes this one. It's more powerful than this. So it takes precedence, and this is logged to the console. So that is what it's trying to say. If variables with the same names exist in both the closure scope and its outer function scope, the variable within the closure scope takes precedence. So you should just be mindful of naming conflicts and all of that. So using let and const in your closures is more preferable than using var. So let and const are to be used, not var. Then the best practices, you should use closures when necessary. You shouldn't overuse closures. Closures and it adds complexity and can potentially impact performance. So you should use them strategically when data encapsulation or private data management is essential. You shouldn't just use closures because you know they exist, something like that. And clarity and readability. You should strive for clear and concise code within the closures to enhance readability and maintainability. You shouldn't just be writing code as you wish. Write code for maintainability and readability, and for performance as well. You should combine these three while writing code. So testing, most of us don't test code. And initially, when I started out, I never liked testing. But let me tell you something. You cannot ship a product to production without testing. Testing is essential. It's very, very important. If you don't test the product, you don't even know if the product will work as intended. But when you test your product before going to production, you are 100% sure, yes, my product is working as expected, and you have confidence in your product. So testing is very, very essential. Ensure proper testing of your code involving closures to catch potential errors and memory leaks and all of that. Okay, so moving forward, that's it for best practices for using closures and JavaScript. And you can always reference our docs and all of that because I've prepared this for a reason. You don't have to miss anything. While I'm talking, I can skip things and talk other things, divert your attention to something else and come back to complete what we're actually discussing about. But when you're reading the docs, you just have to recall what I said earlier, then focus on the docs to get the main point out of it. So that is actually what and everything is arranged accordingly. So moving forward, we have advanced closure patterns. Last but not the least on our list. So under advanced closure patterns, we have coring and partial application with closures. We have memoization with closures, and we have closures in functional programming paradigms. So in closures in functional programming is a broad, let me say it's a broad concept. So we won't be going in depth. We'll only talk about it, the theory aspect, but we'll try to understand how closures are important in that. But we'll give some examples on coring and partial application with closures and memoization with closures. Okay, so earlier we touched an example on partial application with closure where we declared an add function and later binded that function to add 5, and later on the add 5 function will only take an argument of 10, and the result of the initial value, that is the y value, then will be added to the 10 as the x value in our add 5. So I think we'll have to go over that once more and then grab something out of that more than what we really grabbed at first. So, but first of all, let's understand what coring is and what partial application is. So coring is a technique where a function with multiple arguments is transformed into a sequence of functions with a single argument each. First of all, let's get into coring before partial application. I explained that briefly, but this time around, let's go in depth. Let's say we have function add1 that takes x. This returns function add2. This takes y. And inside of this function add2, we say return x plus y. This is coring. Coring as in C-U-R-R-Y-I-N-G. This is coring. And when you call this function, const add1 is equal to, because the add2 is an inner function, you don't have to reference its name directly. You can say, okay, this is the add2 function. We can say AD. We are referencing the inner function, which is add2. We'll say add1. Then we pass in the value of let's say 6. And this time around, we've executed add1, and then we're returning the add1 function we execute, and the inner function add2 will remember the x variable, which is from the parent scope, and we make use of it. Now, when we call add, let's say log add, and we pass in 10. This 10 is this y, because when we call this function, we return this function and we pass it to add. And when we call add, this function requires an argument. So the argument here is 10. Then let's try to execute this function now. 16. 10 plus 16, sorry, 10 plus 6 is equal to 16. So this is coring. And then how can this be done with partial application? Okay, now you can actually say, inside of this, you can say y is equal to 10. And you can call this function here without passing any arguments. You can actually go like this. We have 16, and you can pass 20 here. Initially, y was 10, but when you pass in an argument, y is assigned a value of 20. Now log this function, you have 26. So this is a default parameter, but we'll get to that when we get to ES6. We understand that better. So this can also be partially, this is partially applied. In other words, this is partially applied. And even X, you can actually say 89, 890, oops, 890, let's leave it that way. And you can come here and remove all the arguments. And then you log this, we have 900, 890 plus 10 is 900. Okay, so that's by the way. Now, let's do this in a partial application where we have function add one. This function takes x, y. Then it returns x plus y. Now we just need a single function here. We don't need to go around writing inner functions, closures, and all of that. This is using closures under the hood. So we can see const add, okay. Not really. Coring is it's a kind of duplicating function, not really duplicating, but it's a kind of making decomposing a function, making a function, a single function into two, making it do two things. Instead of writing this like this, you can make it take the first function to take a single parameter and return an inner function that takes another parameter. And those two, there are two different functions, but when combined, they do a single job. So we have, let's say add n. This means add any number. So in this case, I say, let's say add 38 is equal to add bind. Now we're using bind, add one dot bind, no, and we pass in 38. Now 38 here is acting as our default argument to y initially. When I pass y equal to 10, this is actually what we are doing. 38 here is acting as our default value to y. So what we will do now is we say add 38, and then we pass in any value. We can say 34. So log like this. And this will do the same work that our initial function, our closure function did. So if we try to execute our code, we have 72. 38 plus 34 is 72. So this is actually partial application. You are applying the function partially, not fully. You're applying it partially in layman language. That is what you are doing here. You are applying this function partially to add 38 to any number at all. This function here, add one, you are applying it partially, because what this add one is supposed to do is to add two numbers together. But then you take this function and then you change it to add one number to 38. 38 now becomes the constant, and you want to add any number to it, any number at all to it. So that is partial application. And coring, as I earlier said, we demonstrated coring. This is partial application, and this is coring. So I hope we all understand what's going on. By understanding coring, we understand partial application. So we pass in a default value here, and we can actually pass in 20 here, and to do the same thing as our partial application function. It will act as a partial applied function, but the way to do that is the later way. which we did. Okay, so the next item under advanced closure patterns is memoization with closures. So how to memorize with closures. And I think without closures, memoization, it's is it impossible, should I say? Something like that. But what is memoization in the first place? Memoization is an optimization technique where the results of a function call are cached based on its arguments. You know what a cache is? They are cached based on its argument. So closures can be used to store and retrieve these cached results, improving performance by avoiding redundant calculations. Like you have a whole lot of calculations you want to do, and then every other time you call a function, you want that function to recalculate. You want it to, the values to be recalculated. That will take a whole lot of time. So when you memorize, once you calculate for the first time without changing the argument, the result will be cached, and anytime you need those results, they will be retrieved instead of being recalculated. Okay, so let's show that. Let's see how we can memorize values. Now, I want to quickly emulate this function in React, use memo. But because the React team are highly against exposing implementation details, I will just do my own version of use memo so we can see how memorization works. I will just name the function use memo so we can gradually and modify the function to memorize values, and we'll make another one to memorize functions. You know, functions can memorize functions so that, you know, every time a function is called, it is being recreated. That is, anytime it is called, it is being put to the core stack, and then being a local frame is being created. So it's the function is being recreated from scratch. But this time, if you memorize a value, anytime you call that function and the argument to that function doesn't change, it is being cached and the function will be returned. So in this case, let's first of all start to use memo so as to memorize values. So function use memo. This will take in a function. This is the function that will do the calculations. So this cache here, this is a private variable and can only be accessed within this use memo function. And this forms a closure. So this time around, we return a function, an anonymous function that will take some arguments to grab all the args passed into the function. And after grabbing the args, what do we want to do? We will create a key to store the memorized values. So what is the key? The key is, in this case, let's just stringify all the arguments and use it as a key. So we'll say const key is equal to JSON stringify args. So after stringifying this, what do we want to do? We want to check the cache using this key. So we'll say if there is a cache and this key in the cache, that is if the key is not undefined. If the key is in the cache, we'll simply return the value in the cache using the key. We'll return the value in the cache using the key. But if it is undefined, we will store the value in the cache, then return it so that in subsequent calculations, we'll simply return it from the cache. So this time around, let's store, if it is undefined, let's store this value in the cache using each key. You see, function apply is equal to fn. This function here, this function we're taking here, apply this. What is this? Now, you can actually do something like this, but if you don't want to do like this, you can actually call the function and then pass the argument. You can actually, by making it simpler, you can actually call this function and then pass the argument like this. Because if you say apply, it's a kind of we need a more kind of explanation and you get confused. So in this, we return after storing the value, the value in the cache, then we return it. Because this time around we have the value in the cache, so we return it. After returning it, we want to use this function. Let's see, function add a, b, or let's x, y, return x plus y. So let's log something. Log only called at first. Now let's make use of this. We say const mem is equal to use memo, and then we pass in the add. And in the add, we say log mem, pass in. As I call mem now, you can see this. Look at the args we are using. So when we pass in these args, we use them as the key. We first of all check the cache. If the cache is not undefined, we return the value from the cache without any calculations. But if the cache is undefined, that means the key is not found in the cache. We store the value in the cache using the key, and then we return the cache. We return the value from the cache using its key as well. So now we pass 2, 3. Then we run this function. Call the function again. Okay. So now after calling this function, you can see only called at first. At first, these values were calculated, but secondly, we did not recalculate these values. We only retrieved them from the cache. Now, if you want to be sure, you can say log mem 1, 2, and execute the code again. And this time around, only called at first. Now we've memorized at first, the key was not in the cache, so we have to cache it, then return it. So after caching it, we've memorized it. You know how to memorize something. We memorize it so we can remember it anytime. So now, after the second function execution, we've remembered our cache and the key is found in the cache. So we'll simply return the value at that key. So we've returned the value 5. So when we pass in other argument, the argument changed. And when we check our cache, we did not see any key in there. So we have to store the value in the cache, and then the next call, we memorize our value and then return it. So that's simply how memorization works. And as you can see here, we're using closures. This is in the parent scope, and this function is accessing the cache in the parent scope and then using it to memorize in here. So that's simply how memorization works. Okay, so closures in functional programming. We won't go into other examples, but let me just show you. So we can go ahead, look at the examples and current and partial application memorization. This is actually use callback. I also emulated React, but I did not pass an array here. You go over this function and try to play around with it. And if there's any question, you reach out to me on Discord. Okay, so next on our list, that's the last but not the least, is closures in functional programming paradigm. So closures align well with functional programming principles like immutability and pure functions. every other thing is done in the function. And they enable data encapsulation, creating private states and promoting modularity, which are key aspects of functional programming. So closures can be used to implement higher order functions. Always remember that higher order functions are functions that take functions as arguments or return functions as outputs, to further enhancing the expressiveness of functional programming. So in our today class, we explored closures. We learned how to create closures, how to use closures in JavaScript, how to use closures to solve problems. We learned how to use closures in asynchronous JavaScript, functional programming, partial application, and all of that. So if there are any questions, you can go ahead and ask. I'm available to ask, or to answer, sorry. If you have any questions, you can go ahead and ask. For we've come to the end of today's class. So hope you enjoyed the class. If you can't ask any questions here and during your research, you find any, you can always communicate on Discord. Okay, so thank you and see you in our next class.